Everybody, do you know what is the smallest prime number?
2.
2. Yes. And you know, the relative to prime number, if a number is not prime number, we call that composite number, right? We call it composite number. Prime number, that means a positive integer that's only divisible by 1 and itself. Is exactly 2 numbers can divisible prime number. That's 1 and itself. Then composite number, that means they're not only divisible by 1 and itself, but also divisible by other numbers. Now let's see. List every prime number that's less than 20. Is everybody can list? Send me the private chat. What is these numbers? Can you send me this list? Now let's check if this one is correct. So Eddie.
Oh, I missed one.
Wait. Oh, yes. Yes. Okay. Ellie and Rebecca all got this one right. Very good.
It isn't even here.
Yeah, Dago looks not here, right?
Yeah.
Dago is not here. Now let's see. Okay, now let's put it here. Then let's go next example. So the problem is how to check if a number is a prime number. Now let's see how we can check. Is there everybody know 113 is a prime number? Is this one a prime number? Do you know it? So how to check a number is a prime number? This is a question, right?
That's the question?
113. Is 113 a prime number? Now let's see how we can check 113 is a prime number, if it's prime number. So first, you know the smallest prime number, that's 2. So you already list the prime number from 2 to 19, right? So 2, 3, 5, 7, then 11, then 13. I think this one is enough. Now let's check if 113 is a prime number. So to do this, first we need to check if 113 divisible by 2. Definitely not, because 113 is a odd number. It's not an even number, it's an odd number, right? Dago is coming in. So that means 113 is not divisible by 2. So Dago, we are working on example 3.15. Yeah, we try to check if 113 is a prime number. So to do this, then first we check 113.
Don't do prime factorization first.
Yeah, you can try that, but now that not work at all. You say you cannot factor in this one at all. How you factor this?
So we are finding if 113 is odd.
Yeah, we start from the.
We could just start valuing. He's definitely not a 2 because it's not even, and then we could add up the digits for a 3, and it's not 3 either.
Right.
4 is definitely not. 5 is definitely.
No,
not.
you don't need to check 4. So here, this is a very.
Yeah, because we're
Right. You only need to check these prime numbers. Actually.
Yeah, okay,
Say,
okay. And then it's not 5 because it doesn't have a 5 or a 0.
right.
And 7, the rule for 7.
Uh,
it has to end. It has to end. That's divisible, like 149.
right. So
And then 11. 11. What's the rule for 11? No, we forgot 9. 9. No, 9's not.
9.
What about 9?
Because this number not divisible by 3, definitely will not divisible by 9. So you don't need to check about 9.
What about 11? 11. What's the rule for 11 and 13?
No rule for 11. We don't know the rule for 11. You just say here.
It's definitely not 11 because the greatest one would be 121 minus 11, which would be 111. So it can't be.
So first, I want to make sure. I want to ask you a question. So when we need to stop. So say here. First, let me make sure. Everybody, you don't need to check.
You square a number to get like the closest number to this number, and
Yeah.
then whenever you get to that number, it ends.
Right, right. So that means we can just stop at 11. Because 11, when you square, you already got a 121. It's already greater than 113. Okay, this one, that means you need to stop at 11. You don't need to check 13.
Yeah, so this has to be a prime number.
Right. This is the first, the largest number you need to check. It's square root of this number. Roughly.
So now we know that 113 is a prime.
Yeah, we know 113 is a prime number. So second, I want to let you know, you only need to check these prime numbers. You don't need
All the
to.
way to 11, right?
Yeah, you don't need to check the other composite number. You only need to check these prime numbers. Okay? If this number is not divisible by these prime numbers, definitely will not divisible by the other composite numbers, because the composite number also combined by the prime numbers. If they cannot divisible by these prime numbers, definitely they will not divisible by these composite numbers. So that means you don't need to check the other numbers. You only need to check these prime numbers. For the largest prime number, you just need to check that's the square root of this number. So when you square root, say that's largest number, actually that's 11. You just need to check at 11. All other numbers greater than 11, you don't need to check at all. So that means to check this number is a prime number, we only need to check these 5 numbers: 2, 3, 5, 7, and 11. You don't need to check the other numbers. Okay? So now let's see from here.
Can we do 3.6?
Yes, 3.16.
Can we do it like the old times where each person do one problem?
Okay. Yeah, we can do that way. Let's see. Let me give.
Can I do D? Can I do D?
You do D. Okay. This
I'll
for.
do A and B.
Okay.
No, you can't take both of them. I go B and D.
No, we need to give each person should have a number to do.
Whoever finished first. No, that doesn't count. That doesn't count, Ellie. That's not it. I go B. I called double times.
Now let me give this one.
Double times that as B.
Wait. Give this one to Rebecca. Give C to Ellie. This one for Ellie.
Are you kidding me?
Yeah, you do D. You said you do D. Okay.
This is unfair.
That's fine. That's fair. That's fair.
Oh, but why, Ellie? It's already.
Okay.
Oh, why, Ellie? I'm not done. Did mine already.
Oh, you already done? Okay, now let me check.
Not even on the page.
And also, everybody, you need to send me the reason, private chat. What's the reason you make that choice? Rebecca, you need to check. You think the 91 it's a prime number? You need to give me the reason. Now let's see. Ali said 143 it's a composite number. Then Dago said 157 it's a prime number.
That was for A.
Okay, now let me check.
That's my reason. Am I correct?
Now let's see. Yeah, that reason is
Actually,
for.
I think mine is compositive.
Yeah, you need if you think that's a composite number, you need to change your. You write P there, right? Then you need to change that to C. C that means composite. Then you need to also send me the reason why that you think your number is a composite number. Okay, so Ellie, A, that's correct.
That's supposed to be an equal sign. Because of C, 11 times 13 equals 143. So,
Okay, that's right. Okay. Yeah, Rebecca, you're right. This 91 is divisible by 7. Yes. Now let's see. Dago, you did not send me the reason.
Why did it go?
Why this? You think this number is?
Here, but it went back. I can hear it. I see that. Batteries?
100. Now everybody think
Oh, I can't see.
is 157 a prime number? Dago said this one is prime number.
It is a prime number because if you check, it just is.
Okay, so what numbers you need to check?
Well, first you do 13 squared equals 169.
Right.
And then you check the 5, 7, and 11.
Right. You only need to check 2, 3.
Wait. For my problem, can I tell you?
Okay, sure.
So I don't I won't write it in chat. I'll just tell you verbally. Okay, mine is prime because first you have to count 13 to the power of 2.
Right.
That equals to 169, which is greater than 150. So you don't have to count any other prime numbers like 2, 3, 5.
Right.
That was an 11.
Yeah. So that's great. That's great. So you only need to check. Now let's.
This one.
Okay. You only need.
We're not even there yet.
Yeah, you only need to check 2, 3, 5, 7, and 11, because 13 square is already greater than 157. You only need to check these 5 numbers. They are not divisible 157, so that means 157 is a prime number. Very good. Now let's go to 3.17.
3.18.
Now let's do the 3.17 first. Everybody send me this answer. Find the largest 2-digit composite number in which both digits are prime. Largest 2-digit composite number in which both digits are prime. Okay, Ali's answer is correct. Who else? This 2-digit, also largest, then also has a composite number, and both digits are prime.
3.18.
Yeah, you can do that. And send me the private answer, private chat. Don't let others know your answer. So Dago and Rebecca, what's your answer for 3.17?
I just came back here. Sorry.
Okay.
What?
3.17. So
Is mine correct?
your answer is very close, very close. See, your answer, the 9 is not a prime number. You know, they require the 2 digits are prime. Yeah, now you're right. Very good, very good. Dago, we are waiting for your answer. So this problem answer is 77. 7 is a prime number. 7 also prime number. Then 77 is a composite number. This is the largest. Okay, good. Now let's work on 3.18.
Right for 3.18.
Yeah, now let's say find all pairs of primes whose sum is 61. Okay, Eddie got this one. It's right. Is that only one pair you can find it?
Oh man, I sent it to everyone again.
Okay, now we are working on 3.18.
Oh.
What is
Wait,
your
how many
pair?
pairs are there? How many pairs are there?
Okay.
Except mine.
Yeah, everybody got this one right.
Because I sent it to everyone, so now.
Oh, you said to
I
everyone.
wrote it before you came.
Okay. So correct answer is 2 and 59. 2 and 59. No other pairs. Only this one. Yes. Okay, very good. Now let's go to next problem.
It's a 3.19C.
This one. Now let's work together.
I do A.
You want to do A? Okay, now you do A. Okay.
Circle the smallest number that is not already circled and crossed out. Can I do A?
Yeah, you can do B. Ali, you do C. Now let's work together.
Number that is not already circled or crossed out. What does that mean?
Say first, they ask you cross the smallest number. That's.
Is it circle?
Yeah, circle it. Now circle it the smallest number that's not already circled or crossed out.
So I have to circle the ones that he did not circle. Jack did not circle.
Right.
Diego to do the first question, for me to do the second. What do you mean crossed out and circled? The ones that are not supposed to be circled are supposed to be crossed out. So cross out the number that is not supposed to be circled. Like 12. The cross. Now I'll do the crosses first, okay? So what are we supposed to do here?
You need okay. Now let me explain to you. Say you do say circle 2, then circle 3, right? circle the smallest number that's not already circled or crossed out. So you circle 2 first. Then you cross out all the multiple of that number you circled in step 1. So suppose first you circle 2, right? Then you take away, cross all the multiple of 2. So that means you take all the even numbers away, right? Then, except for the circled number itself, you only need to keep 2 there. Take all the other even number away. Then see if every number is either circled or crossed out, then you stop. Otherwise, go back to step 1. So
I'm just circling every single one of these. Wait, what? This is so weird. It's not every one. It's not every one. Then what do you mean by circle the smallest number? Let the cross out 27 also.
say circle first. Dago, let me tell you. First, you need to circle 2, right?
Yeah.
Because 2, that's the smallest number, and you never cross that out. So you circle 2, right?
Yeah.
Circle 2, then you need to do step 2. Cross out all the multiple of 2.
Wait, this is wrong. Why is all of 3 besides 3 crossed out?
Right. Then that means you need to cross out all the even numbers.
I erase it since someone else did, so.
Then after you do finish that, then you need circle number 3. Circle number 3, then you go step 2. Cross out all the multiple of 3.
Exactly. Then why did Ellie said I was wrong? Because some of these are supposed to be circled.
Right.
For Ellie, how am I supposed to know that?
Because some numbers, if it's multiple of the number you already circled, that need to take away. Some number you need to keep there, but you wrongly cross out. That'll be the mistake. Then now
supposed to be circled, I think.
Everybody count how many numbers you left here. This one is a very interesting number. Everybody, after you cross all the number you should cross out, tell me how many numbers you left here.
The ones that are circled?
Yeah. Tell me how many number circled here. Then you can send me the private chat, that number. Now I have the answer for that number.
Some of them are not supposed to be crossed out. So
yeah, if somebody crossed that wrong, you don't need to care about that. You can count that number as circled, then give me that number. You know here somebody got this 9 circle. That's also wrong because that's a multiple of 3.
All these are also supposed to be circled. Just saying. So.
Yeah, you just give me the number. The total should be circled here.
What? Is that correct?
Now let's see, Rebecca, what you said here. That's too many. That's too many.
So what are we doing here?
Now let's see, Ellie, you.
What are we doing here? How many circles?
Yeah, I ask you. Actually, my question is, from between 1 and 100, how many prime numbers here? That's actually is my question. How many primes number are here from between 1 and 100? Now let's see. I think Ellie is correct. Rebecca, you're still too many, I guess, but it's already very close. Okay, Ellie's answer is correct. Now, Dago and Rebecca, you need to count one more time.
I just sent you the answer.
You already sent me your answer?
Did you even receive?
Now let me check.
You
what did you send? I did not get your answer yet.
Let me send it. I guess.
See, we can write down. Rebecca, can you write down all the prime number you found here? Can you write down here? You can write down here. Start from here. This 2 is first, then 3, then keep follow here. See, write down what is the prime number you already found here. So that's 2, 3.
Five's next.
Yeah, 5 is next. Then what is the next one? 7. Yeah, keep right to 100. The largest one less than 100. Yeah. So then you count totally how many there. So this one should be 2, 3, 5, 7, 11. Now let's see, 13, 19, 17. This 17, 19. Then 23, 29. Then 31. 32, how 32 is a prime number? 32 is an even number. 32 is not. 32 is wrong. Then 37, that's okay. 39 is also wrong. 39 divisible by 3.
Also, the next one is 41, but she already wrote that. So.
Yeah, 41, 43, then 47. Yeah, this one, that's okay. Then the last one, it's 53. Then now.
Then I'll write the rest.
Yeah, 53. Then
59.
59. Yes. Then 60. 67. Then.
That's 61.
Yeah, 61. Okay, 61, 67. Then 71, 73. Then then 79, then 83, then 87, no, not 87, 87
No, 89.
divisible by 3. So that's 89, yes. This should,
And the last one's 97.
yes. Okay, this is 89. Then last one is 97, right?
Then there is 1, 2, 3, 4, 5, and then the answer I already got, so I'm not going to.
Right. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, that's 10.
25.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here. Then 1, 2, 3, 4, 5. So totally that's 25 prime numbers between 1 and 100. Or the number of prime number less than 100, that's 25. 25 prime numbers here, okay? Then, let me ask you a question, okay? Do you think how, if we did not limit to 100, if we keep try to find the larger and larger prime numbers, now you see the distance between the prime numbers will become larger and larger, right? So my question is, how many prime numbers do we have? Is that will be the infinity, or that's will become it's a definite number? Everybody think.
Numbers go on.
It still will go on, right? The number of prime numbers will be an infinite number, right? Can you prove this? Now you think the number of prime numbers will be the infinity. We'll have infinity.
If I had time to count forever until I die.
Right. So my question is, can you prove the number of prime number is infinity many? Can you prove that?
There's infinity numbers in the world, and so the primes will keep going with it.
Yeah, the prime number will keep going. Yeah, you know that. That's correct. But can you prove that? So,
Yes, I can.
yeah, now let's see. If you try to prove that, that means you need to prove suppose each prime number I use like P1, P2, then blah blah blah. That suppose this one is Pn. Okay, now I try to prove this one use approach called contradiction. Okay, so that means if let's suppose we only have definitely prime numbers, so that means if the prime number it's a limited number, suppose that stop at n, then this is all the prime numbers we have. Then we'll have a contradiction, okay? Suppose we have totally n number of prime numbers. So that's their P1, P2 to Pn. Then, now let's count this number. P1 times P2, blah, 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 times Pn. Let's time all this prime number together, then plus 1. Let's write this number as x. Let's write this one as x. Then let's see what happened here. Say P1, P2, all this to Pn, all this number.
If you you make infinity numbers on that kind of grid and you tell someone to do all of that, then it'll just be infinity. So yeah.
So here, because we said the number, suppose we said the number of prime number is not limit. It's only this n, only n prime numbers that are there p1, p2 to pn. Then we time this n prime numbers together, then we add 1. Now let's say this number x equals p1 times p2, then blah 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 times 2pn plus 1. Now let's say this x. This x is not divisible by p1, p2, blah blah to pn, right? If you use p1 divided this x, then you have remainder 1, right? Because this part is divisible by p1. Then you got a remainder is 1. Then if x divided by p2, remainder also is 1. Until you divide by pn, you got a remainder is 1. So that means this number x is not divisible by all these prime numbers, right? You know, this x, if you use all these prime numbers divided this x, you always got the remainder that's 1. So that means x is not divisible by all these prime numbers. So what is x? Is x a prime number or a composite number? You know, here that will be a contradiction. You know, say here, x is bigger than all these prime numbers, right? Because x equals the product of all these prime numbers then plus 1. So x is bigger than all these prime numbers, I from 1 to 2 to n. So x is bigger than all these prime numbers, but x is not divisible by any of them. So what is x? This one means x should be a prime number, right? Because x is not divisible by all of them. You know, based on our check 113, right? So we use 2, 3, 5, 7, and 11, all these prime numbers divided this number, then we cannot divisible this number, right? So then we got a conclusion that this number is a prime number. Now this happened for this x here again. We use p1, p2 to pn, divide x. We all got a remainder that's 1. That means all these prime numbers cannot divisible x. So that means x is a prime number, right? But x is greater than all these prime numbers, right?
That makes sense.
So this is a contradiction, right? We suppose only has limited number of prime numbers. That's p1, p2 to pn. But now we got a number x. This number is greater than all these prime numbers. So that means this number should not be a prime number because all the prime number we already here, p1, p2 to pn. But this number you cannot divisible by all these prime numbers. If this number is not divisible by all these prime numbers, that means this number should be another prime number. But we already write all these prime numbers here, p1 to pn. So this is a contradiction. So why this contradiction happened? Because we suppose the prime number is only this p1 to pn, right? But actually, this x should be another prime number. But we did not include this prime number here, right? So this is a contradiction. So this contradiction just comes from because we suppose the prime number is only limited number. Actually, the prime number is infinite many. if we know this prime number is infinite many, that means we should not set the prime number is only like these numbers, no other numbers. Actually, that's not true. The prime number keeps go bigger and bigger, and you never stop. This is our proof. Okay, actually, this proof actually given by the Euclid 2,000 years ago. It's Euclid. It's a Greek mathematician. He gave this proof 2,000 years ago. He already know the prime number is infinite many. Okay, so how amazing is 2,000 years ago he already know how to prove number of prime is infinite many. Okay, so we finished this section. Now let's go to next section. Next section, that will be, let's see, that will be, okay, next section will be prime factorization. This one is very useful. Prime factorization. Say 12. We can write this one as 2 times 6. Then 12, that's the smallest prime number. Then you have 6. 6, then you check if 6 is a prime number. If 6 is not a prime number, then you continue use the smallest prime number divided. Then we got 6 equals 2 times 3. Then we check 3 is already prime number, so that means we are stopped here. Then we got 12 equals 2 times 2 times 3. You can also write that power exponents form. That's 2 power 2 times 3 power 1. Okay? Then after you got this, that means you are done. Okay? So this one called prime factorization. All these numbers here, 2, 3, that's called prime factors. Okay, so if we give you any number, suppose 126, first you divide this number by 2. You write this 2 line segment, write 2 here. 2 divided 126, you get 63. Then you check if this number is still even number. Now it's odd, so that means they don't have factor 2 anymore. Then you use 3 divided. You get 21. So 21, you still check if this one is still divisible by 3. Yes, you get 21 equals 3 times 7. Then you check 7 is already a prime number. So that means you're done, you're finished. So you write this number equals 2. That's, you have 1, 2. So power 1 times 3. You have 2 3s. So you write this one 3 power 2. Then you have 1 7. So you get 7 power 1. So this one will be your result. Write this. Why we require you write this form? After you have this form, then you get a lot of very useful conclusion. Like one, I ask you, how many factors 126 has? Is everybody, can you calculate how many factors 126 has?
What problem are you?
I
What's the
create.
question?
No, I create a
No,
problem.
but what's the question that you asked?
The question is how many factors 126 has? How many factors 126 has? Everybody work on this. Then send me the private chat. How many factors 126 has?
Send you mine.
Oh, you're right. Very good. How you got that?
Oh, I just tried a different factors. I just tried 1, 2, 3, 4, 5, and then I stopped at like 11, as you said.
Okay. Can you see how you can calculate here? Okay, Ali also got it correct. Rebecca, what's your answer for this?
What do you mean?
Observe this power exponent. This one's 1, this one's 2, this one's 1. How you can combine these exponents got your answer. See here, if we do 1, this exponent is 1. No, ask you how many factors you have. I did not ask you what are these factors. Ask you how many factors. If you do this way, you need to list all their factors, then count how many. Right? You can do the normal way. You can just write 1, 2, then 3, then 4, then 6, then 7, then 9, then now let's see 12, then 14, then 21, then 21, then 42, then 42, then let's see, yeah, 42, then now let's see, 63, then 126. Now let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I read something one too many. Now let's see. That's 9, 63. This one's right. 42. 42, that's right. 21, that's right. 14, that's right. 12, that's right. 9, that's right. 7, that's right. 6, that's right. Oh, 4 is not right. This one is not right. No 4, because we only have 2 here. 4 is not, yeah. So we can take this.
One. Okay, I can't really tell.
Yeah, see, that's 1, 2, 3, 6, 7, 9, then 12, then 14, then 21, then 42, then 63, and 126. See, then you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? You got this 12. See, when you do this, it takes longer time. After you get this factorization, you can get that number immediately. You can say this exponent as 1. You do 1 plus 1, then times 2 plus 1. Then you do 1 plus 1. Then you times this 3 number together. That will be 2 times 3 times 2. You got this one equals 12. So 12, that's correct answer. Right? So that's why we ask you write like this way. And this way we can answer a lot of this kind of questions. Okay. So now let's do one problem. Let's say if you can factor this 254. Everybody send me your private chat. What's your factorization of 254 in the powers form? So you can use this sign as the power on your on your keyboard. Use this one as power. So suppose if you try to write 2 power 3, you can tap that 2, then this sign, then 3. That means this one's 2 power 3.
What's the question?
Find the prime factorization of 254. Find prime factorization of 254. So now let's do this. This one's an even number. First, divide by 2. You got a 120.
Don't tell me yet. Let me still think.
Okay, you can do it. Yeah, I just write here. Then you can continue from here.
Are we counting 1? We're counting 1 too.
Yes, we need to count 1 and 254.
Then I got mine.
Okay. Yeah, you're right. So then that means this number is a prime number, right? So we're going to 102 times 127. Then you check. 127 is not divisible by 2 because this one's an odd number. Now it's not divisible by 3 because the sum of digits equals 10. Then it's not divisible by 5 because they did not end with 0 or 5. Then you can divide by 7. They give you the remainder, it's 1. Then that means this one is not divisible by 7. Then we can try if it's divisible by 11. It's not divisible. So then we can stop here. This one is a prime number. So that means we can write this one as equals 2 power 1 times 127 power 1. So then that means number of factor of this number that will be 1 plus 1 times 1 plus 1. That gives you number 4. Okay, so very good. Now let's continue here. Everybody send me your answer. What is the prime factorization of 30? Write 30 as prime factorization.
For 30?
Yeah. What is this one equals?
It's a bit too easy, this one.
This one will equals 2 power 1 times
3 power 1 times.
times 5 power 1. Very good. How about 60? This one will equals 2 power 2 times 3 power 1 times 5 power 1, right? Then 252.
Okay. 2 to the power 2 times 3 to the power 2 times 7 to the power 1.
Okay, now let's see. 252. This is an even number. First, divide by 2. You got a 126. 126 is still an even number. You got a 63. Then that's our number. Divided by 3, that's 21. Then 3, and 7. So that means this one equals 2 power 2 times 3 power 2, then times 7 power 1. Okay, very good. Now 288. This one, 288 is an even number, right? So that means first divisible by 2, you get 2 times 144. So continue 272, then
5 times
236, then 218, then 2 and 9, then that's 3 and 3, right? So 1, 2, 3, 4, 5. So that's 2 power 5 times 3 power 2, right? That's it. Then now let's go 3.21. Find the prime factorization of each of following perfect squares. So this one equals what? This one, that's 2 power 4, right? This one equals 2 power 2 times 3 power 2. That's 4 times 9. Yeah, this one equals 3 power 4. And this one equals, that will be 2, that's 12 square, right? That's 12, that's equals 2 power 2. So that means this 2 power 4 times 3 power 2, right? This one equals this. Now see, how can we use the prime factorization of the number to tell whether or not the number is a perfect square number? So if you have the factorization of prime factorization of this number, can you tell how you tell this number is a perfect square number? You just check for all the factors. Say if you have one factor, if this factor is a even number, that means this number is a perfect square number, right? Say 16, you only have factor 2. So then you check exponents of 2. If it's an even number, say this is a 4, right? That's an even number. So that means this one's a perfect square number. Now for 36, you have 2 factors, 2 and 3. Then you check each one. Say if the exponents of each is a even number. That's 2, this is also 2. So that means this one's is a perfect square number. Now this one, 81, you only have 3. Okay, time's up. So we can stop here. The homework, that'll be
all exercise.
Yeah, all of the exercise. Yeah, we can stop here. Everybody.
Why don't we ever do exercise problems during class?
Because that's too easy. You know, we don't want to waste time there.
Okay, bye.
Bye.